So this is just a short overview about containers and how we're using them at Umbridge. I'll kind of discuss briefly just the background of Docker containers. Then we'll have a look at how they're used in Umbridge. We'll have a look at how to set them up and how to run them. And then I'll give a few notes on using Singularity or Apptainer instead and why you might want to do that. And then I'll end with a brief overview of our models and benchmarks library and also what you'd have to do if you wanted to add your own model or your own benchmark to our library. Okay, so why do we use Docker? Well, I guess firstly, it's really easy to install. So if you've ever used anyone else's scientific software, they've probably given you a huge list explaining exactly how to install it, which version of Python you need or which version of the GCC you need, and all sorts of dependencies that it's got in various places that you then might also need to go and install because they're not part of a package manager and things like this. So if you package up your project as a Docker container, then one of the advantages is that if you want to give that to someone, you just give them the Docker container and they just do Docker run on what you've packaged up, and they can instantly kind of get access to your code. It's also fairly system independent, so you're kind of running in what you could think of as a small, lightweight virtual machine, and so the installation and the running of the model and benchmark doesn't rely on assumptions on the user's operating system or indeed on their packages or software versions. And finally, I guess, in some sense, you get easy access to HPC resources. So this doesn't really come with a Docker container. This comes with the Umbridge integration. But we'll discuss a bit more in the last session about how to use this containerization in order to then get access to HPC scale performance. In particular, we'll walk you a little bit through a Kubernetes configuration for cloud computing, and we'll talk a little bit about how to work on a Slurm cluster and balance that. Right, okay. So as I said before, you can think of Docker as a virtual machine, if you like. It's a little bit more lightweight and standalone than your, conventional virtual machine. But essentially, it's packaging everything up, and it works completely independent from the rest of your system. So the container contains everything that it needs, including, runtime system tools, system libraries, all the settings, everything. And it generally doesn't have any access to anything which is on your computer. So if you want to use something from your computer, you need to copy it into the container. The Docker engine itself looks kind of like this. So it's got a bunch of things in here that you don't need to worry about too much. So this is where all the building, networking, orchestration is happening. And there's 2 points of access to the Docker engine that we've got. There's a Docker API, and what we're going to use throughout this talk is the command line interface that Docker provides us. So those are the entry points here. If you want to play around with this and you haven't used it before, I find that the installation guides from the Docker website itself are really useful. So I've linked the one for Ubuntu here, but it's got for Mac OS and for Windows as well. And they've got a nice how to get started section where, it will explain all the kind of basics. And there's some nice tutorials, or I find these nice at least, at this Dive into Docker website. Okay, so let's try an example. I'm going to, hopefully you can now see also my my terminal window. I don't know how to check whether you can see this. I might just go back here. Oh, now I'm creating this infinite loop again, sorry. I'm just going to assume you can see this. And now we can try to run a Docker container, and the one I'm trying to run now is one which is just provided by Docker. And well, in my case, I need to run this using sudo because of how I've installed it. Depending on what privileges you've given Docker, you don't need to do that. And so now what we see is that it was unable to find this image locally. So Hello World doesn't exist on my computer. So in this case, because it's on Docker Hub, it's trying to pull it from there. It downloads it, and then it runs it. So the Hello World thing just gives you this short little message which explains to you that your Docker installation is working, and gives you some ideas for how to get started. Okay. So to move on slightly, we could try to do something slightly more complicated. So if we run this command, which I'll do in a second, then if you don't already have it, it's going to pull an entire Ubuntu image for you, and then it's going to run this. So there's an IT here as well. So I haven't just written docker run, I've written docker run -it. And the IT is a shorthand for giving each of those as individual flags, where I means interactive. So if we run this, we're going to get put into this Ubuntu container that we've created. And T gives us terminal access to the Docker container. Okay, so I will do this. And so now I'm inside a Docker container. I now have full access to this, and I'm always going to be root as soon as I go into a Docker container. I can have a look at all of the stuff which is on here, and it's basically impossible at this point to break anything. I could, delete the entire directory structure, and obviously I'd break the Docker container, but I wouldn't be breaking anything on my local machine by doing that. So instead, let's just try to start the process of what you might do if you were trying to install your own model as a Docker container. So you'd probably first make apt update so that you have current packages, and then you might install some package. So we write apt install. I'm now interactive, so I don't necessarily have to do this, but once you start putting this into a Docker file, you'll want to make sure that you're not prompted to do anything. So when I do apt install, I always add this -y flag to make sure that I just, install without it querying whether I'm sure I want to do that. And in this case, I'm going to install something called Figlet, which is a completely useless library. You'll see in a second what it does. And then we can use that library. So I'll run Figlet Hello World, and it creates me this lovely Hello World banner if I wanted to do that. Okay, then we can leave the container. Once I leave the container, everything I've done is basically lost. So it's gone forever once I leave the container. Okay. So what we've done now is we've installed some packages, and I'm going to say, we've installed the packages that we need to run whatever application we're interested in. In this case, it's an application in quotation marks because there's no real application going on here. But the process would be exactly the same if you were doing something properly. And if we now would copy the same commands that we've tried in the interactive shell into a Docker file, then that would produce for us a Docker image, essentially, which would be able to run this. So in this case, this is what this would look like. We'd say as a base image, we're using from Ubuntu. So that's the same as me starting this Ubuntu container. Then we need to use the run command in order to do anything that we ran. So then we do the apt update and the apt install. And then there's a slight difference here. So instead of running piglet hello world, which would run that command while we're building the container, we're writing CMD at the start of that, which stands for command, which means that instead this is going to be executed not when building, but when running. So we can give that a go with a slightly more complex example. So in order to build, we'd always write docker build -t, and then we'd give the image name. And then this dot here would just tell it which directory to look for all of the files in. If you have a Docker file in that directory, it will automatically find it. And the Docker file should always just be named Docker file. If you've named it anything else, then you need to specify that name. It's not going to automatically detect that that's a Docker file if it's not called the right thing. In this case, we've got a -t again, but in the context of Docker build, this means tag and no longer terminal, and it gives the image name. So we can name it whatever we want so that later on we can refer to this. Okay. So let's find a nice Docker file to run. I'm now in the Umbrage benchmarks repository, and I'm looking at the Umbrage benchmarks. If I do ls, then I'll see a bunch of different benchmarks that we have available. So yesterday, Catherine showed us all the MUQ Beam example. So let's go in there and have a look at this one. So we can look at the Docker file, and you'll find that this Docker file is really, really straightforward. Instead of building on a Ubuntu-based image, it builds on a MUQ-based image so that it automatically has MUQ installed. It then copies everything from this directory into the container. And then it does basically the same thing that we just saw in the interactive example. We do an apt update, and then we install some Python packages in this case. And then we can just run this Beam model if we want. So that's what the Docker container would look like. And if I do Docker build -t MUQ Beam, for example, then it will automatically start building this. And in this case, it's a fairly quick container to build because it hasn't got anything very complicated in it. One thing to note about this is that the build command, if you've already built something before, is going to find things from your cache. So that means in this case, since I've installed MUQ Beam before, it's just using that and it actually hasn't done anything. And if you want to make sure that you're overwriting that, you can give it another extra input which says no cache, and that will ensure that you then rebuild. So if I did this now, so now you can see it's doing slightly more. It's still not a terribly long process, but now it's actually going through and it's apt installing all of those packages. So sometimes you'll have changed something and Docker won't realize you've changed it, and you'll wonder why each time you rebuild your container, it's still not working, and it's actually because it's still using the old cached version. So I find that quite a useful thing to add in some cases. Okay, so now we've successfully installed this. If we want to see what kinds of images we have on our machine, we can do a Docker image ls. So if I do this now, then I'll see this new Docker image that I've created. I'll also find a bunch of other things that I've used at various points in time. And if I wanted to, I could now also go back and I could delete some of those. And they do tend to get quite large. So you'll see here that even this MUQ Beam is already about 2 gigabytes large. There's a extremely large example here, which is, I think, our cookies problem also from Umbrage. So it's, if you're not intending to continue to use a particular Docker container, then you should definitely start deleting them, because otherwise they'll completely swamp your system. So that was Docker image ls. And then, as I said, we could now go back and we could delete particular images by just saying Docker image im in the name. So in this case, if I wanted to delete this new book beam, then I could either copy that in and use that name, or I could also just give it the image ID. And now it would delete it. And if I do an ls again, then it's gone now. Finally, what I find quite useful is if you want to just automatically clean all of the unused images and containers that are on your system, you can do a Docker system prune, and that's going to go through images and containers. So it's going to look at both. Okay. When we're writing our own Docker file, we've now seen a few examples of the kinds of commands that we use, but essentially we're writing it like it's a bash script, with the only difference being that where in a bash script you wouldn't start your lines with these all caps commands, but otherwise it's like writing a bash script. So the from is always the first thing that you do. It sets the base image that you're building on top of. Quite often that's just going to be a plain Ubuntu, whatever is current. Run executes when you're building. So this is used when you're wanting to install different packages or set up something for your model. And then command will execute those when running. So the difference between these two is just whether it's executed when you do this Docker build or whether it's executed when you do the Docker run command. You can also set different working directories if you don't want to change directory all the time while you're running through your installation process. You can set the work directory to be the current directory you're in, and then it will stay there. You can set environment variables by using env, and you can copy data into the image from your actual machine using the copy command. There's quite a few other Docker commands that you might want, but I think that in the current Umbrage setup, these are the most important ones and the ones people generally use to create their base image. Okay, so let's go through the Umbrage workflow related to this. So everything I've said so far would relate, I think, to any Docker application. So now let's get into the things which are specific to Umbrage. So to create an Umbrage server, we first need to somehow containerize our model. So we need to make a container image which contains our entire application. So that should go from installing all the way to running. And then we need to create an Umbrage server, which will communicate with our clients and then place that also into the Docker container. To run the server, we can then just run the container with that image. We'll need to specify ports for that. You've seen this before in the section that Linus was doing. And then just as if it was one of the examples that we've set up, you would then be able to send requests for model evaluations via Umbrage. If we need to tweak the model, we just update the Docker file, we rebuild, potentially without cache if it's something that we've tweaked, which Docker isn't picking up on. And so that's kind of the general process that you go through for developing such a model. Okay, so this you should all have seen before in the previous session. I'll run through it very, very quickly again. So if we are looking at the client side of things, then we connect to this model by just calling Umbrage model and then giving it our location. So if it's on our own machine, this is the local host and forward. And so this could now be whatever server you've just set up, your new application. Yeah, we can get input and output dimensions, we can evaluate the model, and depending on what you've set up here, you're putting in a different number of input arguments. And we can obviously also optionally pass some configuration options, and you can set up those configuration options in your own model. So if there's some configuration that your application really needs, so not an input parameter, but rather something that you want the user to be able to decide. Like maybe they're picking different types of models, like a hierarchy, as was the example that we had, then you give level, but it could also be other things like, you know, the amount of output that you're giving on your model or anything else. Okay. So the more interesting thing at this point is the model class. So this is what we need to write when we're writing our own application. So we need to define all of the things that the client expects to be there. So we need to define our input sizes. So again, this depends on your application. How large is your input parameters? Your output sizes, which is usually just the quantity of interest. And then you would define a evaluate function. So just what happens when you call the model. This is still the silly small example that you've seen before, which just multiplies things by 2. But if we've just set up a Docker image which has installed a bunch of different dependencies, maybe in Python, then this is where we'd call that. So this is now in the MUQ-beam example, this is exactly where we then call the code which actually creates the finite difference, discretization, and so on, and runs that. And then we just say, okay, yes, this model supports evaluate. Then you can serve it and run it. Okay. So if you want to create your own application very quickly, then you basically just grab the minimal server from our Umbrage GitHub repository, copy it into a Docker file using the copy command, run that Umbrage server where before I had this figlet command. So you write command and then the Umbrage server. And then when you're running, you specify some ports. So for example, 4242. And you'll have the opportunity to try this yourself in the tutorial, which comes right after this. So it will walk you through all of the steps that you need to do in order to do this in more detail than I've discussed them in now. Okay, so we could have a look at what that looks like briefly. You'll have, again, I'm repeating some of the things that Linus has said. I just think it's important that you see how to do this again. So I could run my local version of the XI Tsunami. I was meaning to run the MUQ beam that we just created, but I accidentally deleted it. So let's do this. So now it's listening on a particular port. And instead of writing a proper client, all I'm going to do is I'm going to send it a curl command. I'm just going to ask it to evaluate something. So in this case, I just say, okay, at the port that I've specified on my local machine, evaluate the forward model at the input 10.0 and with level 1. And now if I do this, it's going to tell me that it's connecting. And if I go back to my model, then you can see that it's actually running right now. It's going to take at least a little bit. And at some point, it will produce an answer for us and come back. So in this case, it's just produced these 4 numbers, which give us the wave heights and arrival times. Okay. So the last thing that I wanted to discuss in terms of your Docker container is MPI communication. So quite often you'll want to scale up your application. So you've put your model in a container. That all works. You've put a server which corresponds to that. And now you can query that server with your client. But you'd like to be able to use the parallel capabilities that your model has. So if you're assuming that your model is parallelized, you can easily run with MPI inside the container itself. So you can just, apt install MPI, whatever MPI version you prefer. And then you can MPI run your command rather than just running it. But this will only ever allow us to scale up to a single node because each container just lives on one node. So in a multi-node setting, we need each of those containers to also communicate. And you can't just do that with the base image the way I've described. If you want to do this, then instead of using the base Ubuntu image, you'll need to use an MPI operator image. So you just replace the from Ubuntu with the from MPI operator. MPI operator exists in a few different configurations, so you're not restricted to just the latest Ubuntu. You can specify more, but in the kind of, if I just put MPI operator, then I think it's going to use OpenMPI and it's going to use Ubuntu. But you can change that if you need something else. Okay. And the other thing I want to talk about was how to use Singularity or Aptainer. So why would you want to do this? Well, the issue is that if you're working on some classical HPC cluster, or even just a small cluster that might be administered by your group, then the system administrator is usually not going to allow you to install Docker. It has a bunch of potential security issues, especially on shared platforms with multiple users. And so most system administrators are not going to allow you to use Docker on any cluster. So I don't have access to a single cluster which would allow me to use Docker. So the alternative are Singularity and Aptainer, because these are run entirely in user space, which is to say you can run and set up everything without administrative privileges. So I had to run the Docker each time with sudo, so it had sudo powers, and obviously system administrators are not going to give you those powers when you're running on some larger cluster. So this is why you might need to then fall back to Singularity or Aptainer. The naming is a little bit confusing. Some people say Singularity, some people say Aptainer. It's because this used to be all one big project, and now there exist essentially two forks of the same project, which are owned by different entities. So in this case, I think Singularity by syslabs.io and Aptainer is run by the Linux Foundation. They have, at least currently, pretty much identical functionality. They don't differ too much. Which one of the two you use, really, I don't see any huge differences there. And very often you'll find that they're actually mapped to each other. So if you've got Aptainer or Singularity installed, you can often call the executable with either name. So if your system administrators have installed Aptainer, they might have linked the Singularity command to that, so you can actually also Singularity run your Aptainer. I've seen quite a few systems with that particular setup. There is a really nice guide for how to get started with Singularity by the EPCC, which you can look at if you want to know more about that. And if you want MPI communication, which, because you're now on a cluster, you almost certainly do, then you have to work a little bit harder with Singularity and Aptainer. So you can run the MPI installation inside the container, but this actually has the same problem that we had if we'd done that in Docker, which is to say you will only get MPI on a single node. So then you can try to install MPI inside the Singularity and use both the host and the container. And this is the point where stuff gets very confusing, because if you do this and the MPI versions are incompatible between the host system and your container, then your MPI scaling will essentially not be non-existent, but it's not going to give you any sort of error message. It will just run, but it's not actually MPI running, it's just claiming to, while actually running on a single core. And that took us a little bit to figure out when we started using singularity. So I'm pointing it out here. So what you need to make sure of when you're doing this is that you have exactly the same MPI version inside your container that's already existent on your host system. So generally you won't be able to change the host system MPI, so you have to adjust the container MPI to match what you're doing there. It's also possible not to install any MPI in the container itself at all, but rather to kind of manually bind the host MPI into the container. Intel have a very nice user guide for this, which walk you through various different alternatives you have to do that. Okay. Right, and so the last thing that I wanted to talk about were models and benchmarks in Umbrage. So one of the things that we wanted to use Umbrage for was to allow people to kind of reproduce experiments other people are doing and to try to run UQ methods on slightly more complicated benchmark problems than these kind of standard elliptic examples people usually set up when they're trying to test. Using Umbrage for this has various different advantages. So firstly, if you put a model or a benchmark in, then it will be automatically tested and built through GitHub Actions quite regularly, which means you'll get instant feedback when something breaks. We've got partially automated documentation, so you only need to write the kind of human components of this, so you might explain what your model is for. We can't automate that, but everything that can be automatically deduced from your server file will be automatically documented. And you get all of the advantages of the containerization. So each of the models or benchmarks can be accessed through a simple function call through Umbrage. So if you've got any client in any supported language, then calling these models that are in the benchmark library is as simple as just making a function call. A bunch of these benchmarks are also published in a journal article that just came out, so we're very happy about that. And I haven't put all the authors here, although perhaps I should have, because the list is extremely long and it fell off the slide. So there's about 25 authors on this paper, and it's all of the people who put benchmarks into the library. So various people have given us benchmark problems, and they're all co-authors on this paper. Okay, so you'll already have seen what an Umbrage model is mathematically speaking. So just some function which maps parameters onto outputs. In the context of our benchmark library, a model is really just your forward map, or gradients, Jacobians, Hessians. And so one model might be used at multiple benchmarks. Isn't itself a benchmark yet, right? It's just some application. So you might have a model which corresponds to an inference problem and also a propagation problem. Right now we've got a bunch of different benchmarks, which, as I said, have been all provided by different people. One of the ones that you'll already have seen is this Euler-Bernoulli beam that Catherine showed yesterday and that we just kind of built quickly. And the tsunami example, which Linus talked about, which was one of the first things we did with Umbrage. There's also various other ones. I'm not going to talk through all of them. And then once you've got these models, you can try to build benchmark examples. So these are, in some sense, identical to models in terms of implementation, but instead of defining just a forward model, they define a UQ problem. So if you're talking about inference benchmarks, then they usually define a Bayesian posterior density, including prior likelihood and observations. And your goal when running the benchmark would be to determine the posterior distributions or some quantities that are derived from that. If you've got a propagation benchmark, then you'd give a model, but also a specific distribution that corresponds to that. I've written distribution here twice, I'm sorry. And your goal in this case is to find the distribution of the model output, or again, some quantity derived from that. And finally, we've got some optimization benchmarks, which do the same thing for optimization problems under certain constraints. Okay, so here's some examples of inference benchmarks that we've currently got. If you've looked through read the docs documentation, then all of these are also documented there. And you'll notice now, if I switch to propagation, that a bunch of the models that we have correspond. Oh, these are still inference. Sorry, propagation. So the RWE beam, for example, has a corresponding propagation and an inference benchmark associated with it. And so does L2C. For optimization, we currently only have one example, but again, it's using the same forward model that we've seen before. Right. Okay. But the idea behind the benchmark library was that it shouldn't be a static resource. It should be a community project. We want to have contributions to this. So if you have some model or benchmark with features that are not found in any of the existing benchmarks yet, so this is an important thing. We don't want the repository to get large and then contain 10 times the same type of model. Rather, we'd only want new models which have some feature, something about them that makes them different from all of the other ones. We're also really happy to just kind of discuss this with you. So if you think, I think this is kind of novel, but maybe you disagree, then we're happy to just discuss that. And if you want to add it, then actually all you have to do is make a pull request on our repository. And if we agree that this is a nice new model or benchmark, then we'll add it in. And that's it. If you want to do this, you'll need to obviously set up your Docker file with the Umbrage server, the way that we've discussed now. You'll need to write a README, which follows a predefined structure. There is, as I said, a script which auto-generates parts of this file. So you really only need to fill in the description of what you're trying to do. And if you're putting in a model, then ideally you'd also have a corresponding benchmark that uses this forward model already. You might also have other things that are needed in order to run. So maybe you have some large input data, some additional files in various senses. So you can also add those to the repository. And you can have, of course, more than one benchmark. So if you want to set up an inference and a propagation benchmark with your forward model, then that's great. And you can put both of them in.